Hey guys, welcome back. In this video, we're going to be talking about resolving forces in a horizontal surface, meaning these circular motion examples are going to be uniform. The centripetal force is not going to be varying with different positions on the circle, whereas for vertical planes, the centripetal force may vary with different positions on the circle. So for this example, we have a banked road, which is at an angle theta to the horizontal. So this is following a circular track. It is following a circular track in this direction. So for this, we're going to be deriving and resolve the forces to find out what is providing the centripetal force or centripetal acceleration. Remember, for these cases, it is frictionless. It does not have any sort of friction. The road does not have any friction for these examples. If you do include friction, you have to figure out the component, the horizontal component for the friction as well, but we are not using the surface with friction for this example. So we're going to be considering only the normal reaction force. So first of all, if this car is placed on this banked surface, what are the forces acting on it? First of all, there is a downwards force, which is its weight, which is mg, which is downwards, directly downwards. Now, the other force acting is at an angle upwards on the car, which is the normal reaction force. Now, this normal reaction force, this theta, is going to be equal to this theta, because if this angle is theta, we know this is theta as well. So let's say if this angle is theta, you should already know the angle between the perpendicular and the vertical line is going to be theta as well. So if this angle is theta, you should know that the opposite angle is supposed to be theta as well. So if that's the case, we know the angle between the perpendicular and the vertical line is going to be theta. Now from this we can find out the components. We can find out the components of normal reaction force. There will be one component which is upwards. It's going to be n cos theta. And the other component is going to be exactly leftwards or towards the center. Remember that the first thing that you should be doing for circular motion problems is find the center of the circle. In this case, the center is not over here. It's not over here. It's going to be over here. So the direction for centripetal force is not going to be down over here. It's going to be right over here. So it's going to be in level with the center of mass, let's say. So for the horizontal component, it's going to be n sine theta, which is directly towards the center. Now, again, we are not including friction in this example, so we are not considering the friction force. Therefore, if this upward force is n cos theta and the downwards force on this car is weight mg, that means that n cos theta should equal to mg, because there are no other vertical forces. There are no other even components of vertical forces. Therefore, we can deduce that n cos theta is equals to mg. The next one, for n sine theta, which is directly inwards, there is no force counteracting this this normal reaction force, this component of the normal reaction force. This means this gives you Fc. What is Fc? The centripetal force. So due to the normal reaction force, you're getting the centripetal force, which is the resultant force. Therefore, you can write that Fc is equals to n sine theta, meaning if you substitute the formula for centripetal force, you're going to get mv squared by r is going to be n sine theta. This is another equation. So by resolving the forces, you know that the centripetal force is going to equal to the horizontal component of the normal reaction force. Alright, let's look at an example to clear out the concept. We have the same diagram. The car travels around a circle of radius 200 meters. So the distance from the center to the object is 200 meters in 300 seconds on a surface banked at an angle theta to the horizontal. Granted, there is no friction, find theta. So the car is traveling around a circle. The car is traveling around a circle of radius 200 meters. And how long is it taking? 300 seconds. So from this you can get omega, because you know the time period. So omega is equals to 2 pi by time period, which is 2 pi by 300. So if you calculate for this, you will get 2 pi by 300 is going to give you 1 by 150 pi. So pi by 150. So this is omega, rad per second. So you know omega. From this, you can figure out the tangential velocity. The tangential velocity, which is going to be r omega. You know the radius, which is 200 times pi by 150. So that gives you 4 by 3 pi, which is meters per second. So this is the tangential velocity. You know omega and you know the tangential velocity. Now what do you need to figure out? On a surface banked at an angle theta to the horizontal. Oh, fair enough. So let's move this example. All right. Therefore, if we break down the components like we have already done above, we can say if this is also theta, the vertical component is going to be in cos theta n cos theta is equals to mg, but we don't really need this. What we need is the horizontal component, which is going to be n sine theta. N sine theta is going to give you mv squared by r. All right. So now from these two equations, oh no, we do need this. So from these two equations, you have two formulas. One where you know n cos theta, the vertical component of the car, of the reaction force, equals to the weight of the car. The other is n sin theta, which is the horizontal component, and this is going to equal to the centripetal force. So if we divide equation 1 by equation 2, we will get tan theta, because sine by cos, we will write down it as sine theta by cos theta. N by N is going to give you mv squared by r divided by mg. Therefore, you're getting tan theta is equals to m v squared by rg. Now, from this, you can figure out theta. All right. So v, you already know v, which is 4 by 3 pi. Therefore, tan theta is equals to 4 by 3 pi whole square divided by rg. You know r, which is 200. Yeah, 200 times 9.81. From this, if you inverse the tan, you're going to get the value of theta. So the value of theta comes out to be, all right, 8.94 into 10 to the power minus 3. Okay, so for one thing, I've made up the question, so the values are a bit over the place. But yeah, this is the answer that I've received. So using these two formulas, you can solve for the centripetal force and the angle between the horizontal and the surface on which the car is traveling. Yeah, that's it for this example. We can move on to the next example. All right. So this, oh no. So for this, it's actually an example where tension is causing the centripetal force, right? In this direction. So the object is experiencing a number of forces. First of all, the weight, mg. Second, which is tension, which is upwards at an angle, that is theta, let's say. So this tension is causing the centripetal force, resulting in this circular motion. Therefore, if we want to resolve the forces, we can say, let's take T times sine theta. Sine theta is equals to mg. This is one equation. The other equation is going to be T cos theta. T cos theta is the centripetal force, which is in this direction towards the center. All right. So if we substitute the formula for centripetal force, we get T cos theta is equals to mv squared by r. We can use these two equations to solve a number of problems. All right. So let's look at an example to clear out our concept. T sine theta, and this is going to be T cos theta, which is Fc, and this is equals to mg. All right, so let's look at the example. An object of mass 5 kg is attached to a string of length 60 centimeter. The other end is fixed to a point O. The object moves in a circle of radius 30 centimeter. Calculate the tension and angular speed. I've already labeled it. So the vertical component is t sine theta, t and theta. T sine theta is the vertical component, and the horizontal component is going to be t cos theta. Similar to the previous example. So we can say that t sine theta, because we know the weight, t sine theta is equals to mg. We know the mass 5 kg. So 5 times gravity we know 9.81. And theta we can figure out because it's already given 0.6, which is the length of the string, and 0.3, which is the radius of the circle. So we can find out theta, which is tan inverse 0.3, 0.6. Sorry, cos inverse 0.6 by 0.3. So it's going to be cos inverse of half pi by 3. So the value is pi by 3. Alright, so we know theta. So t sine pi by 3 is going to give you 5 times 9.81. So if you calculate for tension, you're going to get 5 times 9.81 divided by sine of pi by 3. 56.63. T is 56.63, or T is 56.6 newtons. You know the tension. Now the angular speed. How do you find the angular speed? You can find out the centripetal force, which is t cos theta. T cos theta will be 556.6 times cos pi by 3, which is half. So 56.6 times half. 56.6 times half. .3. 28.3 is the centripetal force. So 28.3 is centripetal force. We know what do we want? The angular speed. So we know the mass, which is 5 kg. So we can use mr omega squared. So 28.3 is 5 times radius, which is what? 0.3. 0.3 times omega, which we are going to be figuring out. So 28.3 divided by 5 times 0.3 under root 4.34. Omega is 4.34 rad per second. Yep, 4.34 rad per second. So we know the tension and we know the angular speed. Okay, great. So after this, we will look at a few question papers, I guess. Yeah, we'll look at a few question papers. So see you in the next video.